So first of all, we're going to zoom in for North America with some of the most famous energy storage system manufacturers, meaning Fluence and Tesla. Then in Europe, there will be massive and huge investment to deploy gigafactories, and we are expecting to see local players like Northvolt, Freyr, or Verkor to come up, as well as Chinese or international players investing into their own European gigafactories.
One of the things I believe is going to happen as we transition to more renewable or with battery, which is the solution for a lot of cases, is we're going to see more and more distributed energy systems being implemented. In terms of safety and cleanliness of each of the large energy sources, we can see that basically solar wins on all fronts, wind just behind. In terms of pollution and in terms of human safety factors.
Hello everyone, welcome to this Sinovoltaics webinar about energy storage. I hope you're all sitting comfortably behind your screen. Very excited about today's webinar. We have two great guest speakers today, people with real hands-on experience in the field of energy storage. For those who don't know me, my name is Driekes de Rooij. I'm the Managing Director at Sinovoltaics. Sinovoltaics is a company specialized in technical de-risking of energy storage and PV assets. We're mostly known for performing quality inspections and factory audits here at the factories in Asia. About today's webinar, we'll take about an hour. And when you have any questions, you can type them here at the bottom of the screen. And after the three presentations have been finished, there's a time for Q&A, and we'll try to answer as many questions as possible. Well, we have over 200 subscribers today, so I'm not sure if we can get through all the questions, but we'll definitely give it a shot. Let's have a look at the agenda today. Let me pull up the presentation. The agenda. So we'll have a brief presentation by my colleague and our CTO, Niklas Weimar. He will dive into the topic of qualifying battery cell manufacturers. Then we have Arthur Clare from Easy Renewable. He'll speak about the evolution of the ESS market. We got Jeff from AGreatE, who will speak about ESS Applications. And after that will be the Q&A session. Let me tell you a little bit more about our speakers today. So Arthur, welcome. Arthur is ESS consultant, currently based in Germany, but he used to live here in Hong Kong previously. He's fully specialized in lithium-ion battery value chain, and he will today speak about the evolution of the entire market. Welcome, Arthur.
Hello.
Then we have Jeff Moser. Jeff has also been over a decade now in mainland China. Always had a very strong focus on energy storage and PV, especially about the design and integration of various systems. So to say it simply, Jeff and his team, they build stuff. And you may also know him as the CTO of Syntex Solar. He can explain you more about what he does during his presentation. So welcome, Jeff. And then as a start, we have a presentation by our own CTO, Niklas Weimar. Niklas is fully specialized in quality management of both energy storage and PV. Our team here has nearly seen any PV and energy storage factory here in China and from the inside. And today he will explain more about how to qualify a battery cell factory. So Niklas, we'll start with you. Please go ahead with your presentation.
Okay, thank you for your introduction, and yeah, again, a warm welcome to our joint webinar about energy storage. yeah, before diving into today's main topic of energy storage systems, applications, and markets and main players, let's have a brief look at the preliminary step of qualifying or properly qualifying the supplier for your energy storage project. Now, this is a brief introduction about actually what our company has been doing over the past almost decade actually in terms of energy storage, qualifying actually suppliers, but also performing audits at the basically performing audits, performing inspections at makers of battery cells and also actually of packs. So key parts basically for energy storage projects. This is a basic brief from our side. Now dive more into this topic of actually qualifying these very factories. Now certainly you want to make sure that you work with a reliable and quality supplier. That's of course a given for any successful project. Now while this general phrase is certainly true for virtually any industry and type of product, be it computers or furniture, car engines, or sunglasses. It is even though more important in a relatively still, and from a mass market point of view, a young and, well, we'd even call it Wild West industry, where manufacturers have been mushrooming all over the place, and of which many only in recent years started to catch up on meeting qualification requirements to the required local and international design and safety and performance standards. Now, in this wild jungle of different battery technologies and electrochemistries, a variety of standards and also in view of the hundreds of safety and performance issues recorded over the past decade, actually, and which we spoke about during our previous webinar, auditing your prospective supplier cannot be highly enough recommended. So today we'll look at specifically at auditing manufacturers of lithium-ion battery cells, and let's directly dive into this topic. So when auditing manufacturers of lithium-ion battery cells, there are 5 main areas to scrutinize. First of all, the system and product standard qualifications. So this is basically about whether the manufacturer and its products, or the cells in this case, are properly qualified to applicable, management systems, as well as product design, performance, and safety standards. And here especially it is of interest, of course, also which body executed such qualification. So, for example, was a experienced and renowned CBTL involved, or was it rather an unknown mom and pop lab in some hinterland? So in short, you want to make sure that your supplier and its products meet all applicable international and local qualifications and product design and safety regulations. Then the very implementation of and adherence to such system standards throughout the whole company and by its staff, such as, for example, the quality management system as per ISO 901, is another key aspect to look at. So in short, you want to make sure that all processes in the factory meet applicable ISO guidelines, be it for quality management, with the example of ISO 901, or environmental management, occupational health and safety, and so on. So this is needed actually to produce a compliant and quality product. Then another key area of assessment is about the manufacturer's quality control setup. So during the audit, this involves scrutinizing the level of quality control at the battery cell maker based on best IQC, IPQC, FQC, OQC, OBA practices in battery cell manufacturing. The takeaway here is to identify whether the factory does have all necessary quality checks in place and has its own testing capabilities. Now, a major point of proper battery cell manufacturer audit includes, of course, the assessment of the manufacturing process in the workshops. So does the workshop actually follow industry best practices? Are hygiene and sterility requirements being met, or how do such aforementioned quality, environmental and occupational health and safety standards reflect in the overall operational process in the factory? Now, scrutinizing these questions actually helps to identify whether or not the manufacturer has the structures in place to deliver a safe and quality product. From our practice in auditing battery cell makers, examples of points to assess may, for example, include general requirements about ensuring a sterile, anhydrous manufacturing environment conforming to applicable clean room class levels as per ISO 8 and 9. For example, doing the slurry mixing of the respective electrode paste, or for example, whether proper inline thickness and weight measurements along with imaging inspections of the coating are being performed during the casting of the electrodes. Now, then getting to the last area or audit area, the equipment setup. Basically this involves key aspects such as the calibration, maintenance, proper structural setup of production and measurement equipment, which again is closely geared to the quality and reliability of the battery cell being later assembled in modules and then packs. As there are deviations in the production process for different battery technologies, you certainly want to make sure that you have a specialist and deeply scrutinizing audit procedure in place for the very battery technology in question. In particular, when it comes to identifying issues and non-conformities in the manufacturing process. This is something also which our accredited audit team is very familiar with. So it makes certainly not much sense, for example, to assess a maker of lithium iron phosphate battery cells when the auditor is only familiar with and follows an audit procedure regarding, for example, valve-regulated lead acid batteries. So it should be certainly specialist or focused on the very technology that is being produced and which is to be bought for that project. So when you want to qualify the very source of your energy storage system, the battery cell maker, assessing the manufacturer on these 5 areas will help you to identify and work with the best possible supply partner for your project. That being said, I would like to pass the word on to Arthur now, who will speak about the energy storage system market evolution. Thank you.
Thanks a lot. I'm just going to share my presentation once again. Can you just confirm that you can see my screen? Okay, awesome. So hello everyone, I am Arthur and I'm going to discuss about the energy storage system market outlook. So there are a few questions that I get from my clients about lithium-ion battery energy storage. First one being like, are lithium-ion batteries the sole solution for energy storage? Second one, what are the different kinds of lithium-ion battery energy storage? Where is the lithium-ion market for energy storage going? And finally, who are the key players? So first of all, we are going to answer the first question. And actually, it's pretty easy. Definitely, lithium-ion batteries are not the sole technology for energy storage. So here on this graph, you have multiple technologies used for energy storage. On the x-axis, you have the energy capacity, and on the y-axis, you have the discharge time. So basically, for how long they can discharge their rated power. And so as you can see here, there are multiple technologies going from supercapacitor, flywheel, thermal energy storage, up to pump hydro, which is today, pump hydro, the biggest energy storage technology used in the world, and really by far, and will remain for the next few years. But so lithium-ion batteries are part of the electrochemical energy storage, just like other electrochemical technology like redox flow batteries, sodium-ion technologies, and so on. But today we are going to focus on lithium-ion batteries. So what are the different kind of storage solutions with lithium-ion batteries? First of all, home storage. So those are small solutions with small inverters and 1 or 2 battery modules, usually in the range of 1 kWh to 20 kWh. Then we have a bigger solution with commercial and industrial solutions for C&I clients, with so dedicated cabinets for or small containers for power conversion system and batteries, usually in the range of 50 kWh to 800 kWh. And finally, for the bigger projects for grid storage, we have usually big containers of 20 or 40 foot, either for combined PCS and batteries, or dedicated containers for PCS and dedicated container for batteries. And here we are more in the range of above 1 MWh capacity. And so in this presentation, we're going to focus mostly on C&I and grid storage applications. But also maybe first, before jumping on the market, we're going to review the different applications for energy storage. I would say they could be separated in 3 main categories. First one being customer services with, for example, some backup power and some increased self-consumption. So those are really the right application for home storage and commercial and industrial solutions. And finally, the 2 other categories are ISO and RTO services, as well as utility services. And those are mostly for grid storage solutions, so bigger sites. And so for ISO and RTO services, we have mostly frequency regulation and spin and non-spin reserves. And for utility services, really like energy storage should be considered as a new card in the utility hand to decide if they want to invest into transmission lines, into new peak power generation sources. So really like a new way to have more flexibility on their grid. So now we're going to jump finally on the market studies. And actually in 2021, 2 studies came out that both estimated that the energy storage system market will reach 1 TWh of cumulative installed capacity by 2030. So this is definitely a major boom in this market because that's 30 times the current installed capacity, I would say, compared to 2020. And what we can see here is that there are 3 main regions for energy storage system market. First one being in North America with around 40% of cumulative installed capacity. Second comes Asia Pacific with around 1/3, and finally Europe with around 1/4. So now we're going to focus on the main energy storage system manufacturers around the globe. So first of all, we're going to zoom in for North America with some of the most famous energy storage system manufacturers, meaning Fluence and Tesla. So here, as you can see, there are different colors for this map, just so you can understand this map a bit better. So those are company websites that I have browsed, and basically I combined communicated data for either deployed total capacity for energy storage system for this company. So basically, what are the current operational energy storage system on the field? And so those are in green. And otherwise, you have in orange the deployed or plus under construction plus contractualized energy storage capacity. And actually, you just need also to be careful because some companies, they communicate about the power, the rated power installed or expected to be installed. And some others communicate in the number of energy capacity. But so coming back to our map, now we're going to look at Europe. And so basically what you can see in Europe is that every major European economy has its own champion, with Wärtsilä being the biggest energy storage system manufacturer in Europe. Now going to Asia, and especially in South Korea, we have the 2 biggest lithium-ion battery cell manufacturers, being LG and Samsung SDI, being the two biggest energy storage system players as well. In Japan, we have dedicated energy storage system players here with NEC Energy and Nidec. And finally, we have China with many energy storage system manufacturers. Some are really well known around the world internationally, like Huawei, CATL, or BYD. But some others are less known for people outside of China, than Sungrow, Cloud ESS, and Thermatec. But definitely China is one of the biggest markets for energy storage system manufacturers. And what I'm seeing actually around the globe for the next few years, because today there are many players, I would see a lot of M&A going on and going to take place in the next few years. So a lot of market concentration going to happen. So now we're going to focus on the size of the different lithium-ion battery storage sites. And first of all, we're going to concentrate before 2021 with the NEC Energy site in Gateway in the US being the biggest energy storage site in the world using lithium-ion battery technology with an energy capacity of around 250 megawatt hour. And then we have two sites in China and in Australia of around 200 megawatt hour. And actually last year, so in 2021, something interesting came up is that the three biggest sites that got commissioned in 2021 were the three biggest sites installed ever. Especially for Moss Landing, we got above the 1 gigawatt hour milestone for energy storage, and this one has been deployed by LG Energy in the US. For the two other big sites of 2021, those are in Manatee and in Port Diablo in the US. But for this one, the energy storage system provider is not disclosed. So what I put here are the EPC names. So definitely what you could see here is that the battery sites are getting bigger and bigger. And this trend is going to continue because in the near future, and especially starting in 2022, we are going to break the 2 gigawatt hour frontier in the Eraring power station in Australia. And this trend will continue to go forward for the next few years because we are expecting to have the biggest site in Australia as well in Kurri in 2023, and that's going to reach 4.8 gigawatt hour. So you can definitely hear a trend of sites growing bigger with bigger energy capacity. So now we're going to concentrate on the critical component for every lithium-ion battery cell container and energy storage system, meaning the lithium-ion battery cell. And so here on this graph, you have the top 20 lithium-ion battery cell manufacturers, where you can see that the top 4 composed of LG from South Korea, CATL from China, BYD from China, and Panasonic from Japan, representing more than 50% of the global battery cell capacity, and the top 7 representing more than 75%. But actually, if you switch a bit how you display that data, I think something more interesting come out is that out of the top 20 lithium-ion battery cell manufacturers in the world, 15 are located in China. And the Chinese battery cell manufacturers represent more than 50% of the battery cell capacity. Also, you have South Korea coming out second with the trio of LG ST Innovation, and Samsung SDI, representing around 1/3 of the total battery cell capacity. Panasonic, I would say slightly alone in Japan. And finally, Saft, the only player that is not coming from South Korea, China, or Japan, because they are coming from France. And so you can see there is a huge market concentration in Northeast Asia for battery cell capacity. But this is going to evolve in the next few years, because if we have a look at how the lithium-ion battery cell production are going to evolve in the near future, so here on this map, you have the comparison between 2020 production capacity and 2030 production capacity around the world. We can see that worldwide, the production capacity will move from around 500 gigawatt hour to around 3 terawatt hour. So there is a massive 6 times ratio increase in 10 years. And if we zoom at the different regions, we could see that APAC will remain the main region for gigafactories and for battery cell production, representing more than half of the battery cell production capacity. Then in Europe, there will be massive and huge investment to deploy gigafactories, and we are expecting to see local players like Northvolt, Freyr, or Verkor to come up, as well as Chinese or international players investing into their own European gigafactories. And finally, we have also North America going to expand and to reach, I would say, around 10% of the worldwide production capacity. So even though those figures are, I think, pretty impressive already, it might only be some understatement, because Tesla alone announced that it will produce 3 terawatt hour, which is basically as much as what studies estimate that will be produced around the world. So this 3 terawatt hour map here that we have might only be some understatement. And so it will definitely be interesting to follow up that market. So now I would like to come back to the key takeaway from my presentation. First of all, even though we focused a lot on lithium-ion batteries, please keep in mind that pumped hydro is the main energy storage solution used today and will continue to be for the next few years. Second, 3 figures that I would like you to get from this presentation. First of all, that the lithium-ion battery energy storage system market is definitely booming, and that cumulative installed capacity will reach 1 terawatt hour by 2030. Second, utilities will need bigger energy storage sites, and that in 2022, we are expecting to reach the first 2 gigawatt hour storage site. And finally, gigafactories and investments into lithium-ion battery production capacity are increasing massively, and that we are expecting to reach the 3 terawatt hour milestone for lithium-ion battery cells capacity in 2030, and that's 6 times the 2020 production capacity. So yeah, in a word, there are huge investments and expected huge deployment for lithium-ion battery energy storage system. And it's definitely interesting for you, if you are around this industry, to be updated with the latest market trends and with the latest moves in this industry. That's all for my presentation. Do not hesitate to use the chat if you have any questions, or to reach out to me by email. And I will be pleased to answer your questions. Come back to you, Lucas.
Thank you very much, Arthur. Very interesting. There's already a couple questions that came in, and we'll answer these at the end of the presentation. Let me pull up the slides here, because Jeff, he's going to continue with his presentation about ESS applications. Jeff, are you there? Please go ahead.
Hi, Derikas. Thanks. Thanks for having me. And I just want to clarify that what I'm going to talk about today is more of an application side to energy storage, and we typically are focusing on the lithium ion phosphate battery, not the NCM, which is more used for the transportation sector. And I think some of the slides maybe people just saw there, a lot of those larger factories a majority of them are producing more of the transportation NMC batteries than the field that I'm in, which is the stationary energy storage. And in that case, it's a little bit different manufacturing, and the way that, probably, as Nicholas pointed out before about factory audit, there would be a difference in the way that you audited NCM versus LFP. So what I'm going to talk about today is one of the applications that my company is working on, and how maybe the energy storage, this is actually a crossover between the car, which is NCM typically, and the LFP mostly cylindrical cells that we use. Prismatic cells that we use for our energy storage systems. So as we see, most of the energy storage that today's market is coming from is related to the new EVs. And I'm based in China. Maybe introduce myself first. We're a renewable energy company that sells and develops systems, and that includes wind and solar and battery storage as an inclusive all-in-one package. I'm going to talk about one of our product lines today. It's called the PBC, which is PV, battery energy storage, and EV charging stations. I think this is going to be one of the largest areas of focus for
Okay, that was interesting, but a bit short. I'm sure Jeff is going to come back. We'll
Hi.
give him a moment. Hey, Jeff, you're back. All right.
Yeah, trying to switch the slide, sorry.
Wrong button.
Okay.
Okay.
Okay, so my introduction is comparing, renewable energy first with fossil fuels and where we are today. My slides are a bit outdated, but in terms of getting a general look at where we are, I think, we're in a similar position. So I've got the two largest markets here, USA and China, in terms of electricity and where it's generated from. And I understand there's going to be different markets, different countries that have different better or worse results here. But in terms of these two markets, we can see that the US renewable energy generation by electricity is in 2019 still pretty low overall. Petroleum and natural gas leading the way. In China, we see coal being the main producer of electricity, and renewables, adding, if you want to add hydro with the other solar and wind resources, you have about 13%. So it's still pretty low overall. And as we see the market shifting in terms of transportation, what we see is a lot of EVs coming on the road. And in my mind, I see a lot of attraction for green energy or green-minded individuals hoping that this electric car will solve our pollution, our CO2, our clean energy problem. I think this is only a piece of it. And the other side of the equation is, how is that EV being charged? And this is part of my topic today. This is another slide regarding the energy market. This is in the USA, and part of why I'm showing you this slide is to show you, where transportation sits within the overall energy consumption of the US. And if you look at the lower part of this visual, you'll notice that it mentions that 23.2% of loss for, if you produce electricity with petroleum or natural gas through the grid back to the transportation sector, let's say via EV charging, you're losing a substantial amount of efficiency by doing it in that way. And one of the things I believe is going to happen as we transition to more renewable or with battery, which is the solution for a lot of cases, is we're going to see more and more distributed energy systems being implemented. And what does that mean? I mean, that's basically means is more point of use, which basically translates to better efficiency for our energy use. This is one of the reasons why we prefer to provide energy storage systems with renewable, because we believe that's probably the best way to solve this equation. In terms of safety and cleanliness of each of the large energy sources, we can see that basically solar wins on all fronts, wind just behind, in terms of pollution and in terms of human safety factors. And I think we've got to try to transition a lot of this coal use, which you can see, which is hurting both on both sides of this equation, towards more renewable. And I think the battery energy storage system, the at least stationary version, is going to be part of the way that happens. That's always been the missing link for both those intermittent wind and solar technologies. So how can, stationary energy storage reduce CO2 emissions? It can only reduce emissions if the energy is being generated by clean sources. We do talk to a number of customers that want to use large-scale energy storage to, increase efficiency of their fossil fuel plants. And this is reducing CO2 emissions. It is. But I believe that this is just a transitory job for energy storage, and hopefully in the future it's moved totally towards clean energy generation. So electrification of transportation is where we're headed. I think as we see around the world, so many large car companies are, making their statements now saying by 2030, our whole fleet will be battery powered. If we're really going to do that, I believe that the grid, the renewable energy, the electricity markets are really going to have to play a big catch up. I'm as an engineer, my impression is that there's a huge amount of catch up to do behind to support these large EV transitions. So how are we going to do that? I'm going to try to provide one of our solutions, which is not the only solution. So here's the EV's electricity demand now and moving ahead. And I imagine that these numbers will change as we move forward, but let's use them for now just to get a general perspective. EVs of all types are already displacing well over 1 million barrels of oil demand per day, and that's pretty good, but I think we've got to do a lot better. So you can see here the electricity demand increase globally by 2050 is 8.5 terawatt hours of electricity, and this is a big ask in terms of renewables, or let's say clean energy. It could be nuclear, it could be hydropower, it could be a number of other clean sources. So how can energy storage support EV charging? For us, there's more ways than here, but I'm going to discuss just the main, most important. And one is to increase the return on investment for the system, financially speaking, with arbitrage, buying and selling. There's a lot of countries right now that have a cheaper energy price in the evening or in the late night than they do during the most working hours, early morning or mid-morning, let's say, and when everyone gets home from work. This is a great area for your return if allowed so by the grid companies. The other offer is the voltage and frequency support. As we see more and more large-scale DC charging stations come online, which are 100 to 250 kilowatt, and there's multiple of those all connected together. This can create definitely some voltage and frequency issues in the nearby location with such a large load if they're being used. And this hasn't happened yet, but we're just looking for the future solution here. In terms of off-grid support, there's quite a few areas around the world where maybe you want to put an EV charging solution, yet there's no grid. And if that's the case, do you just put a large-scale diesel generator there and just basically turn diesel fuel into electricity and sell it to people? In our minds, as this is an option, this is not a good option. So using the solar and wind combined in our product line is a great way to offer mid to longer term charging. So in terms of that, our target customers, or let's say our target charging customers right now, and what we believe the future is for a majority of the EVs is going to be in this level 2 area. So there's a breakout of level 1, 2, and 3 of EV charging, let's say, stations. Level 1 being the one most common, maybe at home, people in their garage, they park at home. It's 1.4 kilowatt as stated here, and this could get a little bit bigger, but we're mainly focusing on level 2, and level 2 for us is anywhere from 3.5 to 22 kilowatt is the range that we're looking at. And this for a number of reasons. One thing is we need to pair, in our mind, if we want to have a net zero EV charging station, our solar and battery have to match the EV charging stations. In our mind is what we've seen being done as kind of a publicity stunt, so to speak, is you have a small PV array. You have 6 or 7 50 to 100 kilowatt rapid DC chargers, and people might believe that that energy charging those cars coming from the solar, which, as we know, is totally impossible. The PV array is 10 kilowatts and the EV chargers are combined half a megawatt. So what we've done is tried to put together solutions where the load balances with the generation and the storage. So our solution, the PBC, that's what we call it. It's the all-in-one clean energy EV solution. PV is solar, BESS, and EV charging. And the main goal of this is basically to provide 100% renewable energy for EV charging, which is in fact probably one of the best ways that we as mankind can reduce our carbon footprint, reduce our pollution in the cities, and really, reduce our energy all around. So here's basically our all-in-one solution, what we offer. This can change based on customer needs, but this is just a graphic showing our different inclusions. We have pre-made PBC systems, 30, 50, and 100 kilowatt, but these of course can be customized depending on the customer's needs. So here is basically a graphic showing the 3 sizes that we offer. And remember, this can be done in a variety of different ways. But for us, at our company, one of our goals is to provide pre-configured solutions. We believe that in some cases, this is what people want. We don't want to design and build differently for each and every customer. We do believe that some of these solutions can be a one-size-fits-all for a majority of the market. So in our 30 kilowatt, we offer a 64. You can see the numbers here. You can have a 64 or 128, so it's a 2-hour or 4-hour backup. The PCS is 30 kilowatt. The quantity of the EV chargers could be up to 8, and that depends on the size that's chosen. The larger your EV charger would be, the fewer EV charging units you would want. And to clarify, basically is this: if we connect these systems to the grid, you can in fact put level 3 DC chargers in place. So if you wanted to have a rapid charger included with this and take that energy from the grid, that which of you might not know came from a clean energy source, that is an option. Here's a general look at the charging characteristics, and in a slide previously, we talked about the different EV charging sizes, and level 2 and taking about, I think, 500 minutes for a 60 kilowatt EV battery. So we're going to use that general information to make this graphic here. So what does that mean? That means is if you're using this 50 kilowatt PBC system, what you can see here, it says here 50 kilowatt PBC. If you have a 3.5 kilowatt EV charger plugged into this system, it will take about 16 hours to fully charge that 60 kilowatt EV. And let's just say that's your 60 kilowatt hour Tesla. If you move up in size to the 7.2, you can reduce your charge time to 8 hours and 2.6 for the 22. So our target is dependent on the usage. And you can imagine is most people drive their car and go to work, or drive their car and go to the grocery store, drive their car, park at home, drive their car, go to the movies or to the mall or something like this. And in all those cases, having this type of system set up, if you're charging during your office hours, for me is I could charge in the 3.5 kilowatt time because I'm at the office so many hours. But a majority of workers will be on the 7.2 and can charge their EV full in 8 hours. So this is really dependent on the customer's needs, but it just gives you a general idea of what to expect in terms of charging. This is one of the things we manufacture. So this is how this is all wrapped together in terms of energy storage. AGreatE is an energy storage manufacturer. We are closely linked with a company, EVE, which was mentioned before on the previous slide, for the cells. And this is a hugely important aspect of, safety, longevity, and quality for the long-term usage of these systems. So basically is when we say EVE inside, that means is our cells are EVE. They follow amazing protocols for the quality of building the cells, prismatic cells that we use, the 90 amp hour for, in this case. We also work with them for the 280 larger scale systems, but in this case for the PVC, we're talking about the 90 amp hour. They produce our cells as well as our modules, and we do work together sometimes with them on the pack, but we put together the systems. And most of these systems here are fully UL certified, which is a big part of what we're trying to offer. So UL seems to be the most strict and most difficult certification to pass for both the cell level, the pack level, and the system level. But that being said, CE, IEC standards for different countries, we're also covering. So target locations and why. And I mentioned this before in the previous slide, basically was office buildings is a great place. You go to the office, you plug your car in, the PVC is there, you're charging your vehicle with solar, or the battery has already, been charged by the PV, and then some energy can be discharged from the battery into the EV if need be. Shopping centers, a little bit shorter time period. You might want a little bit larger EV charger there. Park and recreation areas, there's a lot of people that, these areas are very specific to, like, we're off the grid. When you park your car here, you go for a hike, you can charge your car at that.
I currently don't hear you, Jeff. Hey, Jeff, we're not able to hear you at the moment. Jeff, can you hear me? Please have a look at your sound settings.
Can you hear me?
Yes, now it works.
Okay.
Perfect.
I don't know where I got cut off before.
About 20 seconds.
Okay. Here's the general architecture of our energy storage system and the major components. Here's a general look of what's included in our system and how it could look. Here's a general diagram showing basically so people can understand how much. This is a 30 kilowatt layout. This is a single pitch, single bay carport. 8 cars can park in there that are, average car size, and the battery energy storage to the right. So PV is all coming together in the combiner box, and that's something to mention is all these systems are PV ready, DC-DC conversion and DC-AC conversion. We can offer any plug type. Basically, we can also work with companies that want to provide their own EV chargers. So I think there's pretty much all any option is for your EV is here in terms of, let's say, car at this point. So in terms of summarizing all of this, EVs are going to be a big part of the change of the clean energy future. But what we have to do as a renewable energy community to make sure that that happens is to make sure that those EVs are being charged with renewable energy or some sort of clean energy source. If we forget this part and transition our whole fleet globally to EV, and it's all being powered by fossil fuel technology, we really haven't made any significant step forward. So I think this is one of the solutions that we've come up with. There's probably many others, but I appreciate the time that everybody's had. And if there's any questions, you can find my email here, or we can discuss another time. So thank you.
Jeff, thank you very much for this this presentation. I find it very interesting, and I'm sure this is an application that's going to pop up in pretty much any country, and it will be very interesting to see how you will be doing with this application over the coming years. Thank you very much. Okay, let's move on with the Q&A session. We got a few questions here. Let me just pull them up. The first question is I think it's for Arthur. It was the question popped up during your presentation, so I assume it's for you, Arthur. Let me pull it up. It says, how do you expect the price of energy storage and lithium in batteries to evolve in the next few years?
So up to 2021, the price of battery pack and battery cell has go down. I think for 2021, the price went down to $100 per kilowatt hour for battery cell and $130 for battery pack. But actually in 2022, that's the first time that this estimate from Bloomberg actually will go up by like $5 or $10, and those are related to like the price increase of the different components used to do battery cell, so like lithium, manganese, cobalt, and so on. And actually something even more real, if I may say, is that BYD increased the price of some products by like 20% because they were not able to make any margin out of those products. So definitely it's supposed to go down, I would say, but with some bumps on the road.
Right. Sounds a little bit like the PV market pricing.
Yeah, exactly.
All right. Another question for you, or maybe Jeff, but maybe you can start. What are the constraints for using lithium-ion battery energy storage for long duration storage, let's say larger than 10 hours?
Yeah, so I would say to me it is mainly the space and the cost of those systems, because if you go into long duration, you will have usually gigawatt hour scale projects, and so you are competing versus different technology for storage of this energy. So the good thing is that the price of lithium-ion energy storage is going down thanks to the EV market. But also, as I mentioned, it might be also constraints. So I would say cost will be the biggest constraint in the future.
Right. I don't know if Jeff has anything else to add to this.
Yeah, 10 hours is a long time, although this has been done before with the lead acid. It just requires, as said before, is just large build out of more energy storage. I mean, let's say the power and energy are two separate things. So this is a 10x power equation here. So that it makes it quite difficult for that to do that. It's just more money. The longer the duration, the more money you have to spend on the batteries, the larger they have to be. But it doesn't mean you can't do it. It just means that's how you'd have to do it.
Right. Okay. Thank you both for this. Another question. Basically, what's the best battery cell technology for utility scale? Who likes to answer this?
LFP, at least for now, safest.
Safest?
Yeah.
That's the key reason, or are there other?
Well, it's one of the key reasons. I mean, safety's got to be one of our #1 priorities, right? It's like we can't have people getting hurt or fires or any of that. And a majority of the fires that you see in the market are either from NMC or from Second Life. And a lot of times you can't blame this on the battery. A lot of times you have to blame these type of fires on actually the EMS equipment, or the PCS equipment is charging wrong. There's some problem there. The batteries always burn, so people blame that right away because it's easy, but it's not necessarily always the case. But in terms of that question, I would say utility scale right now, probably LFP, and it will be. China's really pushing hard on this in terms of manufacturing. If you look at Asia, LFP is all in China, majority. If you go to Japan and Korea, you see more of the NMC.
All right. Okay. Thank you, Jeff. Let me see what else we have here. Question for Arthur. Thanks a lot for the interesting presentation, says Carl. If you listen to the news, you hear a lot about Tesla's new cell design and improvement in cell production. However, they don't appear in the top battery cell manufacturers. How would you explain
that? Sure. Can I still share my screen?
I'm pretty sure you can.
Right. It will be much easier to answer that question. So, very good question. If I may, so if you just remember this graph that I shared, so you can see in the top 4 manufacturers, you have LG Chem, CATL, BYD, and Panasonic. And actually, 3 of those are working directly with Tesla. The most close partnership is with Panasonic. So what you can see from the data from the Tesla gigafactories in the US are actually considered made by Panasonic from this study. And for also Tesla is supplying cells from LG Chem, and also for China mostly a lot of cells are coming from CATL. So you're right, Tesla is not in this graph yet, but I would expect that with Tesla's new development into their new battery cell design, that they will really be considered as a really sole battery cell manufacturer in the future. So you should see them in the next studies.
Okay. Thanks for this, Arthur. Nick, I got a question for you. Are you there, Niklas? He is here.
Yes.
He says, hey there, interesting webinar. Question from Stefano. He says, my question to Niklas, which are the reference standards for quality checks of cells as well as for cell manufacturing / production? Bit of a technical one. I don't know if you know this from the top of your head.
Well, yeah, I mean, there's 2 things probably to look at. So first of all, I mean, for the audit itself, or basically for qualifying the factory, and this is probably meant with that question also for references, so to say, or reference standards. I mean, for the audits, we have, of course, our own proprietary procedure for auditing manufacturers. And again, it's and again, Geoff pointed out, is quite, of course, technology specific, right? So you need to assess a manufacturer based on the technology that's being manufactured there, or like the battery cell type or the electrochemistry. when it comes to standards, well, there's a huge variety, and it depends really on what what kind of technology, again, or electrochemistry you are working with. So for example, for lithium ion, you have like famous standards like UL 1642 for lithium batteries cells. Then you have like IEC 61619, which are the safety requirements for secondary lithium cells. Then you have also, again, standards for the modules and the racks. Again, also there's like UL standard 1973. So there's quite a variety to look at. I mean, for just lithium ion itself. And then generally you can, what is important, for example, and applicable to lithium ion batteries is like famous UL standard, UN standard, UN 38.3, which relates to the transport of basically these battery cells. So during the previous webinar, I mentioned a couple of incidents, right, that happened, and for a variety of reasons. And there's, of course, requirements for these batteries to before transport, basically, that they also qualify to this. So UN 38.3 is an important, actually, qualification, and it's actually very product specific. So you cannot just apply this to like in one go to all different products that are being made. So it should be basically for each product type. And then again, you have like standards for example, for lead acid batteries, also from the IEC. So to make it really short, I mean, it's really specific when it comes to the product that is being made and the electrochemistry basically being involved. And that applies both to the IEC, UL, whatever, international and local standards, and then also to the audit procedure itself.
Okay. It sounds like you can talk half an hour about this topic, but maybe it's a nice topic for a blog post or something, because all these standards, right? It sounds like a good topic for a blog post. Okay, thank you, Stefano, for this question, and Nick for the answer. Question here: is there a tiering system for large energy storage suppliers like the Bloomberg Module Tier 1 for PV modules to select bankable storage systems?
I do have something to say on that.
Go ahead, Jeff.
I read every, I don't know, month or so, you put out your newsletter regarding this. It's not really bankability, but it gives you a general list of the score. Atman?
Yes. Yeah, the LMC score ranking report. Yeah, it's every quarter.
Yeah. So I mean, of course, Bloomberg is also there, but you got to wonder is, how do they get their information? What are they basing it on? So one of the things I've seen, and we're working with our supplier with, I mentioned EVE before, is that UL is offering bankability, not a certificate, but it's a study. So there are such things in the market now that are available. I mean, it's really in depth. UL was at our office, this past week, and we're discussing it and what it requires, and it's quite intensive. But there are bankability, and there will be more bankability options coming for the large scale. And I do think it, just like PV, it will follow in PV's footsteps for that.
Right. Yeah, that's interesting. And just to mention the ranking report. So what you were referring to is a report that we publish every quarter. It's about three types of components. It's modules, inverters, and energy storage. And what it is, it's an LMC score ranking, and the LMC score is a bankruptcy predictability model. So it practically tells you what chance you have that a factory is going to go bankrupt within now and 2 years' time. It doesn't give you a full bankability picture, but you do want to consider if a factory is financially stable and if they're going to be able to honor their warranty terms to you over the long term. And that's just one factor, one variable that you take into account when you make purchase decisions. Let me post a link here in the chat. This is a direct link to the reports. So if you type in that link on the website, you can download ranking reports straight away. Okay, and actually next week there's a new one coming out, but it comes out every quarter. Okay, thanks, Jeff. Let me see what else we have. A moment. Okay, this is a question for Jeff. Question from Marcin. Everybody are focusing on fast charging, but what we do at home or not necessary. In Europe, we do around 50 kilometers a day. Do we need fast charging or slow down? Charge 10 kilowatt per day per 6 hours at home or work site, give us 2 kilowatt charging access. In other situations, yes, fast charging needed. Okay, do you understand the question, Jeff?
I think I do. I mean, there's a couple things I want to talk about here because this question is exactly the application. Is it going to work or not? And I think the answer is yes. I mean, I think the way we use our EVs will be a bit different than the way we've used traditional gasoline cars, because now we have the option to basically pump our own gasoline from the sun into our car at home, which before we never had this opportunity, or at work or something like this. The other one is going to come around is this EV to grid situation where, you know, the EVs are actually providing grid support from their batteries. When I was in grad school 15 years ago, this was part of the design for the future of our grid, is that the EVs would be there to, you know, take power when needed and also give it back. In terms of this specific question, our plan is the level 2, which is right in the range that he's mentioned here in his question, which is, you know, anywhere from 3.5 kilowatt to 22 kilowatt. And that sweet spot there, we believe, is that most people can charge, you know, 50 kilometers probably takes an hour or two with a, you know, a level 2 charger. This is perfect. You know, you go to the supermarket, 1 hour, you can get all the mileage back that you took driving there if you want. Right. So I think the way that we charge our car is going to be a little bit different. I mean, you can plug in all over the place. This is a little bit different style. It's kind of like your phone. I mean, really, like people going around everywhere. They go home, they plug their phone in. They go to work, they plug their phone in. You know, they go out to eat, they plug their phone in. It's going to kind of be like that. Anytime you need power, you're plugging in, rather than a replacement, which is kind of what the gasoline style is. So I think the rapid charging is maybe useful if you're on a highway and you know you need to pull in and, you know, 5 minutes later your EV's charged. But I did want to mention one thing I forgot to mention before. It's probably not indicative of that EV's battery. It's not good for it. Yeah. To be charged at such a high C rate. Okay. This is like one of the things for us in energy storage is always the question is asked is like, what's the C rate of your application? And if you're 1 C or less, okay, that fits within the warranty range of, you know, the 5,000 cycles that we expect, 10-year life. If you're going to charge 100 kilowatts, kilowatt hour vehicle in, you know, in 5 minutes, this EV charger is going to be huge. So is that affecting the longevity of your Tesla battery? And my guess is yes. And I also guess is that eventually some of these EV companies are going to say, if you do that, you're going to lose your coverage. So I do believe it goes, that point is to go back to, do you need this, you know, high DC charging station? The answer probably no. For everyday general lifestyle, if you're traveling across the country, maybe different story. But if you're generally living in one area, go to work, come back, go to the movies, come back, pick your kids up, come back, then this size is perfectly fine.
Right, right. There's another question from Iberg, which is very closely related to what you've been talking about. So he says the main problem of this project was it's too expensive when you use PV modules and battery energy storage at the same time in the PVC. Isn't it going to be better if we don't use battery and use the grid with net metering?
I would say is this, to answer this in two different ways. When I first moved to China, solar panels were $4 a watt. Now they're 25 cents a watt. I hope I didn't blow anybody's cover. But now you can see in that period of time, the price going from $4 per watt down to, you know, the price I mentioned. This is a huge reduction. And I often have this conversation with my business partner here, Dr. Xu, who is part of the team that developed the lithium-ion battery over at Binghamton University in New York, and ask him this question: what's the price going to be? Can we reduce it that much? And he says yes, but maybe not as much as PV. But that being said, is innovation can drive the cost of anything down. And if it does happen to follow the cost of PV, then this problem mentioned won't be a problem in the next few years. Okay, so it is cheaper, of course, at this very moment to just buy an EV charger, plug it to the grid, plug it to your car. That's the lowest upfront cost. But in terms of midterm, longer term cost, the PV and PV plus battery might be cheaper depending on where you live.
Right, right. That's what we all aim for. That will change the game. Okay, there's another comment, but this is a comment from Les. Someone living in South Africa sees an influx of EV-powered cars, but very little clean charging solutions. Well, you know, seeing charging solutions is one thing. My brother, he recently drove from Netherlands to south of France in an EV, and it was an adventurous trip. He eventually made it, but he had an app where he was supposed to see every EV charging station on the way. And we even signed at the gas station that he was very near to this EV charging station, but then he arrives and it was still under construction. It was not physically there yet. And it makes for an adventurous trip. But then clean charging is the next step, right?
I think we have this chicken and egg problem. I mean, if we have no EVs on the road and then my company or other companies like us begin to develop this, you know, even just EV charging stations, there's no return. There's no cars. So it kind of is, the EVs move out a bit. Behind them come the charging stations. The EVs more pick up, more charging stations come. I think this is kind of just the natural evolution of how this evolves, unless the governments get involved and just say, like, we're going to build 100,000 EV charging stations in 2 years, and if there's EVs there or not, we don't care. I don't think most countries are doing that. So, you know, they're very spread out. You need an app to find them. But you know, if you look at the history of gasoline cars, 100 years ago or more, this is the same issue. You know, there's no gasoline station. So, now you drive around, they're everywhere. So this took time. And I know everybody's in a hurry to switch to clean, vehicles and all of this. And I'm also excited about that. But I think we need some patience when it comes to this.
Right. Okay, we've been going on well over an hour now. It's still a lot of people on the call. Let's say we answer one more question. I guess Arthur, you'll be the one most suitable. I mean, Jeff may be also able to pitch in. Arthur, if you're still there, there's a question here. What other near-term battery chemistries for energy storage are there available in the market?
So That's a very good question. So actually, if you focus on the lithium-ion batteries, there are already in that field major developments going on, and that are going to be released in the next few years. So I'm thinking about solid-state batteries and some new battery chemistries. So if you get out of this lithium-ion battery and you focus on other technologies for energy storage, what comes to my mind are redox flow battery, so like vanadium redox flow battery, for example. And there are definitely like sodium-ion technology, nickel-cadmium technologies. There are many electrochemical actually technologies, like dozens, to be honest. But I think like in the next few years, it will be mainly like either flow battery or lithium-ion battery.
Right. 1,000 different chemistries. That's interesting. The future has a lot to offer.
If I just may, I love talking about this subject, and from what I've heard, because the Japanese, I think, at least in that area of the country, got stuck on their technology, and that's why the Chinese moved to lithium iron phosphate. They didn't want to wait around, and they wanted it. And because they had heavily invested in the factory manufacturing equipment, they wanted to stick with that technology, because changing to the new technology requires a huge investment. And I've probably been to 6 or 7 cell factories that just make the cell, and they are enormous, and the amount of money involved in building this is hundreds of millions and hundreds of millions of dollars, and the people and training, and this is a huge business. So in my mind, I hear this sodium ion battery is like really like a lot of cycles, 100,000 cycles. If we can get that, great. But I think if you get it in the lab and you want to get it to the market, is like a huge bridge you have to cross, because the lab is one place and the market's another place. Investing in all that equipment and getting people to give up the old technology is difficult. So even if we have that sodium ion or lithium metal in the in the laboratory now that works, getting mass production might take time.
Right. Understood. All right, guys, let's wrap it up for today. Arthur, Jeff, thank you very much, and Nick, of course. Thank you very much for these very interesting answers. We answered nearly all questions from the participants here. The webinar is going to be available as a recording, so if somebody wants to rewatch it, we're going to be putting it on the website within a week or so. Thank you very much for attending. We'll be doing more of these sessions. We hope to have you back, both Jeff and Arthur. It was a very interesting session today, and it will be interesting to check in a few months and see what you guys are working on. Thanks again, and thank you everyone for attending, and we'll see you again. Bye for now.
Thank you.
Visit Sinovoltaics.com to learn more.